Good morning everyone. My name is K. Pranavi and my roll number is 234G1A0488 and my topic in ECA is Relaxation Oscillator. So introduction. Oscillators are classified into two different categories. So before I get into the what are the types of oscillator, so we need to understand what is meant by oscillator. So an oscillator is a device which can give output signal even though we didn't give the input signal. So basically the oscillators are divided into two types, that is linear and relaxation. In linear we'll get the sinusoidal outforms and in non-linear we'll get the that is relaxation will get the non-sinusoidal waveforms. A relaxation oscillator is a type of electronic oscillator that generates a non-sinusoidal repetitive uh, output signal by repeating charging and discharging a capacitor or inductor through a resistance until the threshold is reached, then rapidly discharged. So in the relaxation oscillator we use capacitor or inductor or MOSFET, any other type of devices which can store the energy so it can charge and discharge, which we get the repetitive output signal, that is square wave or sawtooth, etc. The design of relaxation oscillator must include nonlinear elements like transistor, op-amp, MOSFET, and energy storing devices like capacitor or inductor. To produce a cycle, the capacitor and inductor charge and discharge continuously, and the frequency of the cycle or the period of oscillation depends on the time constant. So this is the circuit diagram of the relaxation oscillator when we used the op-amp. So when we give when the input is taken here, so it generates a signal, that is the signal as output. Because we used because of the capacitor, it charges and discharges, so we get the output signal as like this. How does a relaxation oscillator work? The relaxation oscillator incorporates energy storing devices such as capacitors and inductors. These components are charged from a power source and discharged through a connected load. So basically here we use the capacitor or inductor, which are the energy storing devices. So when the input signal is given, it stores the energy, so the waveforms increase drastically, and when it discharges it decreases. So because of this, the shape of the output form is of the relaxation depends upon the time constant of the circuit. Key characteristics and the concepts. So basically there are some key characteristics we use in the relaxation oscillator. They are time constant, threshold voltage, hysteresis, and fast low systems, and non-linear behavior. So components of the relaxation oscillator. Capacitor stores electrical energy and releases it at the controlled rate, which is fundamental in generating oscillations. Inductors, when used, influence the rate of oscillation by adding to the time constant of the circuit, shaping the waveform output. So basically we use the capacitors to store the electrical energy and it releases it in a controlled rate, so which actually is useful in generating oscillations, whereas the inductor we use it for the rate of oscillation. So when the rate of oscillation is added to the time constant, we get the our desired shaping of the waveform output. So transistor acts as a switches or amplifiers controlling the charging and discharging of capacitor. And why we need transistor is that so when the signal when the capacitor reaches its highest threshold voltage energy, then the transistor acts as a switch, so it can off and on based on the charging and discharging of the capacitors. And diodes ensure that current flows in only one direction, safeguarding the components and stabilizing the oscillation frequency in some configurations. Resistors limit the current flow, affecting the charging time of capacitor. They are crucial in setting the frequency of the oscillation and ensuring stable operation of the relaxation oscillator by connecting the time constant of the circuit. Working mechanism. The principle of operation in relaxation oscillator revolves around the charging and discharging of capacitors. As we have seen from the previous slides too, we have been studying about the charging and discharging of capacitors, which is the major thing in the relaxation oscillator. As a capacitor charges through a resistor, the voltage builds up until it reaches the threshold and triggers the discharge, initiating oscillation. So when it reaches certain level of the level, then it triggers the discharge, then the oscillation starts at the waveform at the output signal. Feedback loops are crucial in relaxation oscillator as they help maintain continuous oscillation. The frequency of the oscillation in relaxation oscillators is determined by the value of the resistors and the capacitors in the circuit. The time constant defined as the product of the resistance and capacitance directly influences the rate of charging and discharging, thereby determining the frequency. Types of relaxation oscillators. So uh, uh, we have seen what is meant by relaxation oscillator and working mechanism and key characteristics. So now we are going to uh, know how many type of relaxation oscillators are there. There are mainly two types, that is a stable and monostable multivibrators. So a stable circuits continuously oscillates, creating square waves. Meanwhile, a monostable circuit generates a signal output pulse in the response to a trigger. So these are some of the applications of the relaxation oscillators. Relaxation oscillators are widely used for the signal generation in various electronic devices. They can produce signals of different shapes, including square, triangular, and sawtooth waves, making them essential for the audio applications, clock signal in digital circuits, and as local oscillators in radio receivers. In timing circuits, relaxation oscillators serve as reliable sources for generating precise time delays. These are key components in applications such as timers, delay circuits, and frequency modulation, ensuring accurate and dependent on the circuit resistor and capacitor variables. So what does this mean is, so the output waveform is a square, triangle, and sawtooth, right? So based on the square wave signal, we can generate timers, delay circuits, and frequency modulation, and digital circuits for the clock systems and all. So, and let us see some of the examples. And a stable multi-vibrator is a type of relaxation oscillator that continuously oscillates between two unstable states, producing a square wave output. It's commonly used in timing application and clock pulses for digital ICs, offering simplicity and versatility. Triangular wave oscillators produce linear and rising and falling waveform. They are often used in the audio synthesizers, function generators, and for shaping various signal in various applications due to their linearity and ease of generation compared to the wave. Sawtooth wave generators produce a waveform that rises and abrupts falls, resembling the shape of the sawtooth. These oscillators are widely used in video signal generation, sound synthesis, and testing application, particularly for their unique waveform characteristics. So we have seen the applications, right? So basically, the applications are used in many devices and all. And as for the examples, these stable and triangular waveform oscillators and sawtooth wave generators are used across various communication systems, that is no mainly in the processing systems, that is audio processing and video processing signals, so which was very useful for us in our day-to-day life. So conclusion: relaxation oscillators are integral components in modern electronics, providing critical functions for signal generation, timing, and waveform creation. Understanding their mechanism and application allows for innovative uses in various technological advancements. So we have seen the mechanism and how it works, the key characteristics, and working principles, so and applications example. So these relaxation oscillators are used in the modern electronics, which are a very critical functioning for the signal generation, timing, and waveform creations. So by understanding this mechanism and applications, which allows us for the innovation uses in the various technologies technological, that is developing things. Thank you.